Hi guys, today I am going to explain about the construction of PDA from context free grammar. I think you all know what is meant by context free grammar and how it represents and how the PDA also represents. PDA means a push down automata and CFG means context free grammar. See guys, by taking an example, I am just explaining it. So in this example, I will clearly explain how to construct the PDA from context free grammar. Okay, guys, now let us see the example. This is the question, that is construct a PDA that accepts the language. So, guys, this is the context free grammar, that means this is the language. So, here we need to construct the PDA, and another thing also they represent that show an ID for the string ABAB for the PDA generated. Either they may ask the question in this way, or they ask that what is or show the string acceptance. They also can represent that string acceptance. So we need to prove that whether this string is accepted or not by the generated PDA. Okay, see the answer guys, how to represent. This is the first step. Okay, in the first step, we need to check the given context free grammar is in GNF or not. GNF means what guys? The form of the GNF is non-terminal tends to single terminal into string of non-terminals. String of non-terminals. If the given context-free grammar is in the form of GNF, we need to proceed. If it not in the form of GNF, we need to convert it first into GNF and then we need to proceed. See guys, first check whether the given grammar is in GNF or not. GNF means guys, non-terminal implies single terminal into string of non-terminals. See guys, this is the non-terminal. So this is the single terminal into string of terminal. Then check for B. See, this is the non-terminal and it is a single terminal into string of non-terminals. Then see here guys, here it is also single terminal. So it doesn't consist of any single terminals. So it will also exist because it has another form. Non-terminal tends to single terminal. So it also exists. So for A, it is terminal and it is non-terminal. So it is also exists. These three are in the form of GNF. Now let's see that the second step is first the start symbol yes. We have the start symbol. This is yes. So yes is pushed onto the stack. By how we will push guys? By using the formula that delta of Q naught, that is it is initial state and epsilon is the input symbol and Z naught is the top of the stack. So this is the top of the stack, input symbol, and it is an initial state. So here we are pushing the stack. So here we have epsilon. So we are taking the next state. That means new state we are taking. It is the new state. So this is the yes symbol. This is the input symbol what we have pushed and it is the top of the stack. Now for the production, now see for the next production guys. So just here for yes, for in construction of PDA, for every step, the first step is this only guys. We need to convert the epsilon into yes. Then for the production, yes tends to AB. We need to check for this. Here, first of all, we need to write the that is the state, that is Q1. Here Q1 state we have this, so the same state we are writing here. Then input symbol. What is the input symbol? Small a is the input symbol. And what is the top of the stack here? We just pushed the S into the stack. So it will be the top of the stack. So S is the top of the stack. Here by pushing AS, we are writing B in place of these two. So in place of these two, we are writing B. Next check for B tends to BA. Here guys, for A tends to AB, B tends to BA, and then B tends to B also we need to check. So B tends to BA. That is how we want to check. This is delta of Q1 B. It is an input symbol, and this is the top of the stack. So in place of these two, we are writing A here. There is no change in the state. Only one time we will push yes. So for that only we need to change the state. For remaining all, we are taking the same state. For B, I wrote it here. Here, B doesn't have any non-terminals. So in that time, we need to replace B by a lambda. So we are replacing B by lambda. So for A also I wrote here A is replaced by B. Then the step is, and this is the final step guys, third step. The PDA for the given context-free grammar. So this is the PDA. What is the formula for that? Is a formal definition of PDA. M equals to Q sigma. We will represent it as a tau or tape symbol, and delta Q naught Z naught F. So what is the Q value guys? Q naught, Q1, Q2, and epsilon is AB. These are the input symbols. Tau means the non-terminals along with Z naught. These are all the non-terminals along with the Z naught. So Q naught, that is the initial state Q naught. Z naught is the top of the stack, and F value is Q2. So this is the final state. So here delta, already these are all the delta functions. These are all the transitional functions. This one here from these are the transitional functions. So we will write the transitional functions here. Then now we constructed the PDA. This is the construction of PDA guys. Just writing the formal definition of PDA. So in that formal definition, we are representing the all the values of the symbols. Then now we need to show that an ID for the string AB for the generated PDA. So we need to prove that AB is accepted by the generated string. So how we will prove that guys? See here guys, in our first step in proving this ID AB string. So delta of Q naught comma epsilon equal epsilon comma Z naught tends to Q1 comma S comma Z naught. This is the first line. Then here just now we got the top of the stack is yes. We just pushed the S into the stack. So top of the stack is yes. Then here we are writing the string here, and this is the top of the stack. So now check for Q1 A yes. What is the value of delta of Q1 A comma S? See guys here, delta of Q1 A comma S tends to Q1 B. So the same thing I wrote here guys, Q1 B, it is pushed into the stack, so BZ naught. Now in place of S, we are replacing it with B. Top of the stack is now B. Then for delta of Q1 B tends to, here we will get that Q1 of delta of Q1 B tends to Q1 A. So here Q1 B tends to Q1 A. So the top of the stack is B is replaced by A, Z naught A. Now for A, this is the top of the stack is A, and then Q1 A B. Here we are writing that Q1 B Z naught. So the top of the stack is B. The things guys, whatever the input symbol we are computing, we are just removing it from here for the next step. So here A removed, and here B removed, and here now we are removing A and writing that Q1 B, the top of the stack is B. What's the value it has guys there? Delta of Q1 B tends to Q1 comma lambda. So Q1 comma lambda Z naught. So then again here B is replaced by Z naught. Now all are completed, and what is the input symbol we have here? Only lambda. On top of the stack is Z naught. So what we will get? Q1 comma lambda. So this is our answer, guys. So it will say that the string is accepted. So we proved the string acceptance. For all questions and problems, at last we need to get the final state with lambda. Whatever the final state you will consider, with that we need to get the lambda. Then it is the here we have acceptance. In acceptance PDA we have two types. One is empty string, empty stack, empty stack, and the next thing is a final state, final or finite state. Now here this is the, if we got the lambda, we will call it as empty stack. In place of lambda, if we got the Q2 or QF, that is final state, comma Z naught, this we will call as final state. This is the delta of Q1 lambda Z naught tends to Q2 Z naught. Either we will write in empty stack or final state. I think you all understood my lecture. If you have any doubts, please comment in the comment section. Thanks for watching my video.